Welcome back. In this session, we want to discuss these two important descriptives for two population data, and they are covariance and correlation. So when we talk about descriptives, we are talking frequently about a summary of a population of data or a sample subset of data. A summary in the sense of one number that summarizes all the numbers in the population or sample. And depending on the definition of the descriptive, we can use that summary, that's a summarial number for different purposes. So, for example, if we use a central representative, we like a number that kind of centrally represent the cloud of data points. We can use average or median. If our intention is to talk about dispersion or fluctuations of the data, about their means, then we can talk about variance or standard deviation. So that much we are quite familiar. What if we have two variables situation, two measurements that are done at the same time of a given item or a given occasion, such as a student, a person's height and weight, such as a person's or a student's GPA and the number of hours spent in studying. So when we perform two measurements and notice that they are all of different, or they may be of different units of measurements. It can be time and money. It can be GPA, indexless number, and time in hours. It can be dollars and dollars, or it can be square foot and dollars. All right. So what if we perform measurements of two measurements, not one measurement, but two measurements of a set of items that are of interest to us? It can be a set of people, right? Employees of a company. It can be a set of people, such as students of a class. It can be a bunch of properties in a particular area. So we can measure, of course, amongst various things, the area and the price, the selling price. Are they related to each other? So when we have two measurements, we also like a summary of these two measurements. That is not two numbers that separately summarize the two measurements, but one number that summarizes the two sets of measurements. So that is the motivation of coming up with these two descriptives, covariance and correlation. And since correlation depends a lot on the understanding and definition of covariance, let's understand the definition and motivation for covariance first. And then it will be quite easy to move ahead to understand why we also need correlation, right? So the first few bullet points basically are to define, based on formula what they are. And then the last 2 points will be quite sort of different branch of development based on covariance and the correlation that we learned earlier on. So let's understand the motivation of covariance, because once you understand why we need it so much, then it's way easier to appreciate the formulas and the definition. So if we go to the next slide, right, we see a bunch of formulas and all that, but that is less of a concern right now, because what I like to do is to move us to this part of the screen where we are able to understand a little bit better based on a picture, right? So allow me to just quickly sketch something. So we have a bunch of data. Okay, it can be anywhere. But then, so we have a bunch of data here, all right? And we can, of course, out of convenience, say that they are all positive in in measurements. So they are all on the first quadrant. But that is actually not going to change much because the data can be plus minus or of any adjusted to any units or scale to any quantities. It doesn't really matter that much. What is important is of course the sea level, right? The where is the sea level, where's the sort of natural reference point of the x values and also the y values. So if you kind of look at the extent of the horizontal span of the data, and then roughly you can say maybe the x bar is going to be here. So let's just say we have calculated x bar, the average of all the x measurements. And the x measurements can be anything, you know. So for example, we can think of it as weight. Just an example. It can be, of course, square feet of a property, and the y value can be height of a person. And of course, for property, it can be the selling price. Yeah. For airline mileage, it can be miles flown versus points gathered. Well, that of course is artificially managed as one-to-one. But say the points that we earn and the resulting flight equivalent value, right? So we exchange for a flight and then find out about the market price of that flight, see whether there is any connection between them. So when we perform those measurements, notice that each point is based on one particular item in the physical world, right? So it can be a property, it can be a student, it can be a particular flight ticket value, all right, based on points gathered, and we exchange for that. So all these points are gathered, and for clarity, I will not put in too many points. Just let's say 5 points to illustrates a little bit of variation and um, non-triviality. So we can say that the vertical span has an average of about y bar here. And the horizontal span has a centrality around the x bar here, let's just say. So no matter how many points you put, a lot or very few, you find that there will be these two lines, right now. So they will form the natural reference level, the sea level. I like to call it the sea level. So what's next? Well, based on the sea level, so it's more about this central crosshair than the side axis, right? So with any data points, you can think of it as the data points will always occupy these four quadrants, all right? So certain cases will never happen. For example, all the points are here, all the points are here, you know, all the points are gathered in one quadrant. That's not possible. All the points are gathered in um, half quadrants. It's not possible, right? I'm just showing one quadrant. Of course, any one of the four quadrants, it will not be possible because we're calculating the central point of the x and the y's. Yeah. So notice, take note that these cases will never happen. Yeah, and of course, it will also be not possible for data points to gather in all three quadrants uh, and not well, this could happen actually. So this could happen, or all four quadrants. So this is possible, this is impossible, this is impossible. So what is possible is that you have somewhat of a balance. Yeah, so this is possible with maybe sprinkle one or two dots here and there. That's possible. So all these are possible. So that's the kind of situation we are in. All right. So our case here with 5 points, it's quite a fair uh, illustration here.